This is 2023 paper 2 question 5. We're given some information here. We need to find the mean and the standard deviation of the red cubes. So the mean is easy enough to work out, but because we have to find the standard deviation, you could do that by hand, but you may as well use your calculator for all of it, because standard deviation is a bit of a pain to calculate. So we're going to go in statistics on our thing, and we only have one variable here. We just have the number of red cubes, and we want to type all those in. So we're going to have 3, we have 0, and then 3, 2, 2, 4, 5, and 1. You can see we have 7 things there, so we're all good. So then we can go out of that, and we can go to options. We can look at the one variable calculations. So x bar is up there at the top. Might be a bit difficult to see, but x bar is what the mean is. So it says to one decimal place, so it's going to be 2.4. And then the standard deviation is going to be, well, it's denoted by sigma. So sigma squared is called the variance. Sigma x there, that's going to be our standard deviation. You can see it's 1.59. So to one decimal place, we'll write that as 1.6. So the mean is 2.4. Standard deviation is 1.6. Then we have to figure out the correlation coefficient between red cubes and the green cubes. So we're going to have to redo this. So you can turn on the calculator. And this time we need 2 variables. So I'm going to go back in statistics, and now we're going to use y equals a plus bx. Because if you think about the correlation coefficient, it's like, and you think about drawing the line of best fit, it's always a straight line. So that's why we want y equals a plus bx, because that'll do the best straight line fit. And then for the x, I'll just put in the red cubes, and for the y, I'll put in the green cubes. So for the x, we'll have 0. Well, I'm going to have to put them in individually. I'll just do that. So I put in the values there, just type them in. So then I can clear that. I can go into the options. Now we want to look at regression calculations, and you can see R there. R is the correlation coefficient, so it's 0.762 if you were to go into 3 decimal places. Sorry, it's minus 0.762. You can see there's a minus sign in front. It's just a bit hard to see on the screen. Then we're told, why would you expect the correlation coefficient to be negative? And the reason for that is because what he's doing is he has some cubes, right? And he's taking out random cubes. And then he says, how many of each color do we have? So if you take out like a lot of red cubes, that means that there's less green cubes. So to explain that a bit better, it's like look at trial A, for example. If I didn't pick out any red cubes, well, that means the only cubes that I did pick out were green or blue. So that means I picked out more green cubes. Whereas if I picked out mostly red cubes, because I'm only picking out 5 in total, let's say if I picked out 4 red cubes, well then the maximum number of green cubes that I could take out is 1. And in this case, it's 0. If I take out 5 red cubes, well then that's the total number I take out. That's going to be 0. So basically, like, if we take out more red cubes, that means we can't take out as many green cubes, because we have to take out 5 in total. So that's the reason why they're negatively correlated. There's the answer from the marking scheme. It's essentially what I just said there. Then we're given a little shape here, and we're told to fill in the blanks pretty much. So we're asked, what's the number of cubes with 3 faces on the outside of the cuboid? Well, you can see here one is highlighted, and it's going to be the ones on the corners, right? Because, for example, these only have 2 faces, and the ones on the centers only have 1 face. So how many corners do we have? Well, we're going to have 8 corner pieces. So that's going to be 8 with 3 faces on the outside. How many have 2 on the outside? Well, you can see the ones with 2 on the outside are the ones between the corners. So we have 1, 2, 3. We have 4 there. 5, 6, 7, 8. And then we're going to have the same on the bottom, right? So here we have how many in total? We have 8. And then times 2, because we have the same thing on the bottom. And then how about around the sides? Well, we're going to have 2 here, 2 here, 2 here, and then 2 in the kind of middle slice on the other side. So that's going to be plus 8. So that gives us 24 in total. It's going to be 24. How many cubes will have no faces on the outside? Well, if you just think about the inside shape, you can see that the inside shape is going to have kind of like a thickness of 1. They're going to be in here, and they're going to have a height of 2. Like, if you thought about removing all these, it's kind of hard to visualize, but imagine you took this pane off, this pane here, and you took this pane off as well. Well, then these one, and you took these off, well, then we end up just having a little kind of gap in the middle. And how many would be in the middle? The answer is 6. Again, the reason for that is just, if you imagine taking, well, I guess you could imagine taking this front face off and the back face off, right? And if you do that, you just have kind of a thickness 1 slice in the middle, but then we also have to take the top off and the bottom off. So then we have only 2, and it's going to start here, and then it goes across 3. Because originally we went across 5, but if we're taking off these 2 sides, well, then the length is going to be 3. And originally the height was 4, but if we take this side off and we take this side off, well then the height's only going to be 2. And yeah, that's pretty much it. Well, actually, to finish that off, if we take this side off and this side off, well then this is only a thickness of 1. So we have 3 by 2 by 1 is the dimensions, so that's going to be 6. So yeah, it's kind of abstract, that one, but that's how you solve it.